All right, topic 10, test review. Starting with number 1, I do want everyone to have a calculator just so we don't have any calculator questions tomorrow. So on this one, it wants us to find arc length and area of a sector. So making sure you read directions. What is the arc length formula?
Angle of the arc measure divided by 360 times 2 pi r.
Yes. Okay. So
have those equations on the
nope, you got to memorize them. Yep. So these formulas need to be memorized. Okay. So
Maybe get a little cheat sheet.
nope. Filling in this angle measure. What is the angle measure of the diagram? 120 out of 360. And then what is my radius? 9. Okay. So in your calculator, you're gonna type this in. 120 divided by 360. Hit equals.
0.5.
And then multiply that by 2
Wait, 0.
and times 9. What you should get is 6, but we didn't include pi, right? So I would leave 6 pi. If you did include pi, you would get 18.8. If you do that, use the pi button, not 3.14. Okay, I will accept both of these answers. Okay, I only need one of them, but you can either use pi or leave pi out. Okay, so I don't care which answer you give me for that one. Okay. It also wanted what? Area of the sector, okay? The sector that's shaded. So these formulas are very similar. What am I multiplying by now?
Pi radius squared.
Pi r squared. Yep. So what is my angle measure still? 120 out of 360 times pi. What's the radius? 9 squared. So again, type this in first. 120 divided by 360. Multiply by 81. If you left pi out, you would get 27 pi. If you were to multiply pi through, you would get 84.8. Again, I will accept either of those answers. I do not need both of them. Okay. These will be 2 formulas you need to know. All right. Number 2. I know, kind of hard to see, but I think I fixed it for the test. But on this one, it wants to know if AB is tangent to the circle. How do I prove if this is a tangent line? True. What are we actually trying to prove? That there's a right angle involved. Okay, which we know if it's given side lengths, we can use Pythagorean theorem. Okay, what would my C value be?
The hypotenuse.
It would be the hypotenuse. Do I know that yet?
Yes. Yeah.
I can find it, right? Is it just 4.5?
No.
No, I'm missing this here. What can I assume that is?
It's a radius. 4.
Yeah, it's a radius. So if the other radius is 4, this one also has to be 4. So this whole side is 8.5. So our C value is 8.5. What can I use for my A value?
4.
4 squared from here, and my other one? 7.5 squared. What do we want to do once we have this filled out? Just like evaluating, right? So from here, I'm going to take 4 squared is 16. 7.5 squared is 56.25. 8.5 squared is 72.25. What do I do from here? Add that left side together. I get 72.25. Does that equal 72.25? Yes. Okay, so what does that yes mean? That it is a tangent line. Okay. There is a bonus IXL like this for you guys, and I had a great question yesterday. It looked like this: 72.25 equals 72.3. Would that be a yes or a no?
No.
That would be no. Why? They're not exactly the same. Are these super close? Yes, but are they the exact same? No. So you have to make sure, even if it's 1 decimal place off, you have to make sure they're the exact same. Okay. All right. Number 3, still working with tangent lines. Wants to know the perimeter of the polygon. What do they mean by polygon?
Like the kite.
All right. Are we talking about the circle?
No.
No, we're talking about the shape on the outside. What is that shape made out of?
Tangent line.
Tangent lines, okay? So this is a formula, or not a formula, sorry, a property that we talked about with tangent lines. I'm just going to use this as an example. From the point of tangency, so where that tangent line is, to the outside, what do we know about these 2 tangent lines?
The same.
They're the same. So if that side's 7.2, what's the other side have to be? 7.2. Okay, there's a pattern that we kind of have to follow here. Okay, so I'm just going to keep working my way this way around the shape. What would this side be right here? 6. Can I just assume this side is also 6? No. How can I figure that out?
Subtract 6 from 7.
Right, this right here gives me the whole side length, so I can subtract those. Why did I want to do that? Why did I care? Right, it helps me find this other side, which would be 11. What would I get for this side right here? Yep, subtracting those, okay. And then our last side that we're missing has to be 6.2. We're seeing the pattern happening. It's kind of like a puzzle piece that you have to work your way around. Is that what it wanted?
No.
Right, it wants the perimeter, which means
All of them.
add up all of them. I'm just going to start here, work my way around. So I get 7.2 plus
6.2.
6.2 plus,
2.
correct. What could I use for this side?
7.2.
Yep, I could use the whole thing. Yep, or you could use the two different pieces there. What about the bottom? 17. And the left side? 6. 7.2. If I add all of those together, you will get 60.8. Okay. All right, backside number 4. It wants us to find the missing angle measure, which is the question mark here. So I'm going to label that X. What kind of angle is that?
Inscribed.
It's an inscribed. How do you know? On the edge.
Tomorrow.
Okay. What do I need in order to help me find this angle measure?
The arc of RF.
Right, I need its arc measure. Why would that be helpful?
Then you can divide it by 2.
Because then I can find the angle measure. What piece of information do I need to use to help me out?
The half circle is 180.
Correct. I have this line right here that goes through the center. What's that called? Diameter. How many degrees is that line? 180, which makes its arc measure also 180. So from here to here is 180 degrees. So how can I find this arc measure that I'm missing?
114 from 180.
180 minus 114 is 66. So now that I have its arc measure, how do I find its inscribed angle measure?
Divided by 2.
Yes, 66 divided by 2 is 33. Okay. What piece of information did I need to know, or else I couldn't have solved this?
180.
Yeah, we use the diameter here. You will use that multiple times. Okay, if I didn't have that, I wouldn't be able to solve this problem. Okay. Yesterday, some of us were using this as the diameter.
No.
Why can I not do that?
Doesn't go
It doesn't go through the center. Yep, make sure if you're using the diameter, it has to go through the center. Okay. Awesome, nice job. Example 5. Given circle A, it says BC and CD are the same. What are those lines?
Chord.
They are chords. Okay. Wants us to know the measure of arc BC. What is the only thing I know the measure of in this diagram? The angle A. How can I use that?
The two angles are equal.
I can find this arc here. What is that arc measure?
78.
Why?
Because it's arc.
It's a central angle. So remember, central angles and their arc measures are the same. How does knowing this help me know this?
Because they're equal.
Right. If their chords are the same, that means their arcs have to be the same. Okay. Awesome. So that one is 78. All right. Let's look at number 6 through 8. Can I just look at this diagram and answer these 3 questions right away? Why not?
Oh, no.
The directions give you information. Okay, so it says measure of angle AGC is 90. So I'm going to mark this as 90. What kind of angle is that?
90.
True. In regards to the circle. Central. So if this is 90, what's its arc measure?
90.
Also 90. Okay. It also tells us that AC is congruent to DF. If I know that, what are these lines right here? They're chords. So what can I assume about their arc measures?
They're the same.
They would have to be the same. So what's this arc measure here?
90.
Would have to be 90. Yep. Good. Also tells us that AB is equal to EF. Okay. All right, let's look at number 6. It says angle AGB is congruent to what angle? Thoughts?
FG.
Yeah, why? What gave it away?
Cause FE and AB.
Yeah, it tells us their chords are the same, so we know their angles have to be the same. Does the order that you write this in matter?
Yeah.
Yes. Okay, you got to make sure the angles match up. This one says measure of arc BC is 50, and it wants to know the measure of arc EF. Do those correlate with each other at all?
Yeah.
No, you find AB first, and then you can.
Correct. They don't relate to each other directly, but what do we know EF is congruent to? AB. How can I find AB? Yep. 90 minus 50 is 40. Good?
6. Can you flip F and E?
No.
No.
You gotta have the same order. Good question. Segment BC is congruent to segment ED. Yep. I do not care about the order of those because it's just a line segment. Okay, I'm probably not going to be too picky about this either, but you do want them to match up.
Wait, but like in the directions it says A and B is congruent to EF, so wouldn't that mean like E and F are the same? So shouldn't E be first? Okay, never mind.
All right, on this one, there are two different ways you can solve this. Okay, I will show both because one way might work better for someone else than the other. So, wants us to find measure of angle 1. I'm going to mark that as X. So, they gave us this arc measure here. Do these two correlate with each other at all? Like,
No.
do they relate whatsoever?
No.
No. Okay. If I were to have that arc measure here, do those correlate with each other?
No.
Yes. Okay, but unfortunately we don't have that. What's going to help us here?
180.
What do you mean 180?
Like the line.
Diameter here is 180. So do you agree this arc measure is 180?
Yes.
Okay. Why does that help?
Because you can subtract stuff. 114 from 180 and divide by 2.
True. I'm going to come back to that one. Do you agree those two arcs relate to these two angles?
Yeah.
Okay. What do I know about those two angles?
Vertical.
They're vertical, so that means they're the same. Okay. How can I find an angle on the inside of the circle that is not inscribed or central? I'm taking the average. Yes. So how would I take the average of those two arcs?
180 plus 114 divided by 2.
Yep, 180 plus 114 divided by 2. Which, if I add those together, I get 294 divided by 2, which is 147. So this angle here is 147. How does that help me find angle 1?
Subtract it from 180.
Yep, because we're on a straight line here. So I can just take 180 minus 147, which gives us 33. That's one way you could do it if you remember the average. Okay, let me erase my picture here. Let's talk about the other way. Okay, still using the diameter. But do you agree I can assume this arc on this side is also 180? Okay. I'm missing two arcs here. What do you think I know about those?
They're equal. The vertical.
Right, and what do I know about their angles here?
They're equal.
They're equal, so we know their arc measures would also have to be the same. So, using that, I just labeled them both X. What can I say about all three of these? They add up to 180, so I can say 2X plus 114 equals 180. And then it just turns into algebra. So how do I do the algebra?
Subtract 114 from 180.
Yep, 2X equals 66. Divide by 2, I would get 33. So it does not matter what route you do, you will get the same answer. Okay. What piece of information did we need in order to solve?
Diameter.
Diameter. Yep, again, we use the diameter to help us. All right, number 10 and 11, we're talking about the equation of a circle. This is another formula you will want to remember. Okay, to write the equation of a circle, it's x minus h squared plus y minus k squared equals r squared. What does the center stand for?
HK.
Center is hk. And what about radius?
5.
With r, yes. What happens when I plug h and k into an equation?
Your son.
Their signs switch, right? So how would I write the x version?
X plus 7.
X plus 7 squared. Do I need the 0?
No.
No, what happens?
Just y.
Y squared equals Yep, because our r is 5, but square that, we get 25. So that's my equation. Okay, so this here is another equation you're going to want to know. Number 11, it gives us the equation this time. We want to figure out what the center and the radius is. So remember, center is h and k. What do I do when I pull that out of the equation?
Flip their signs.
Flip the signs, so our center would be 1, -4. And radius, is it 9?
No, it's 3.
Right, 9 is in the place of r squared, so to get r, I need to square root to get 3. Number 12 and 13, using this diagram, wants us to find measure of angle CDE. Okay, what kind of angle is that? Inscribed. Okay, what's going to help me find this angle measure?
The arcs.
I need to know its arc measure. Can I find its arc measure? Yep, just add those two pieces together. 90 plus 64 is 154. So if its if its arc is 154, how do I find its inscribed angle? Yes. So 154 divided by 2 is 77. Okay. Let me erase here. Let's talk about number 13. Number 13 wants to know arc CD, which is here. Does arc CD have its own angle measure? No. If it did, it would look like this. Okay. Can I just assume that it is 64? No. Okay. What is CD a part of that we can find?
ECD.
True. It's a part of this angle here, which is a part of this whole arc. Correct. Its angle right here is 62, so how do I find the arc measure? 62 times 2 is 124. So if the whole arc is 124, how do I find what's missing? Yep, 124 minus 64 is 60. Awesome. So just remember, I can't just assume these are going to be the same. 14, it wants to know the measure of angle 1. Where is the measure of angle 1 at?
Outside.
Yeah, in regards to the circle, it's outside. So there's only one way to find an angle on the outside. It's the Farknark, okay? If that doesn't make sense to some of us, it is the big angle minus the small angle, and then what? Divide by 2. So I'm going to take 98 minus 54 divided by 2, which is what? 44 divided by 2 is 22. So wherever you have an angle on the outside, you're going to subtract the 2 arcs and divide by 2. Okay, what if I were to flip-flop these?
That'd be impossible.
Why?
Because you get a negative.
I would get a negative. Okay, is it possible to have a negative angle measure? No. Okay, so keep that in mind. If you're getting a negative, you might have to switch some things around. Okay? All right, 15 through 17, these are the ones with the different segments. So on these, you have to ask yourself what kind of lines you have. So on number 15, what kind of lines do I have? 2 chords. How do I find the length of a chord?
No, part equals part times part.
Yes. Part times part equals part times part. I'm going to put equation up here, and I want you to tell me what's wrong with it, because this happened on our homework a lot.
No. You can't do that.
Right. Where do the 2 parts have to come from?
Same line.
They have to be on the same line. Okay, are 15 and x on the same line? No. So if it helps, outline it. What makes up this chord? 12 and x, so 12 times x. What makes up the other chord? 15 times 8. Again, what are we doing with these two? Multiply. So we have 12x equals 120. Again, algebra from here, what do? Divide by 12, x equals 10. Once you have these set up, it is just algebra from there. Okay. So when you have 2 chords, part times part. 16. What kind of lines do I have on 16? I have a tangent and a secant. Does it matter which one's which on the side of the equal sign?
Yes.
No.
Let me rephrase that. Does it matter which one I put where?
No.
No. Okay? Reason I wrote it like this is just so we can talk about their equations of a sort. So, since I wrote secant first, let's talk about it. How do I write a secant line?
8, and then times in parentheses 8 plus x.
Correct. If I put this into words,
I'm not gonna remember that.
it's outside times
Total.
total. What does it mean to find a total of something?
Add.
Add. Okay, so what is the outside of that line?
8.
8 total.
8
plus x.
Correct. I can write x plus 8, or can I have these flip-flopped?
Yes.
Yes. Okay. What about the tangent line?
It's just square.
Right, we take whatever that tangent line is and we square it. So what is my tangent line?
12.
12. So I square it. Yes. Algebra from here. I'm going to write something and I want you to tell me what's wrong with it.
No.
You didn't do it to both, just
You gotta
to both.
distribute it.
Correct. A lot of us remember this part, but we have to distribute to both. So we get 8x plus 64 equals...
144.
Right, do I just want to like square root this? No. Just type this in. 144. From here.
Minus 64.
Yep, just algebra from here. Subtract 64. So we get 8x equals 80. Last step.
Divided by
Divide by 8. X equals, bless you, 10. Awesome. And then number 17, very similar. What kind of lines do we have on 17?
2 secant.
2 secant lines. We already talked about how to set up a secant line. How do we do that?
Outside times total.
Outside times total. So for this line, what's the outside?
8.
8 total.
X plus 8.
X plus 8. Okay, let's talk about the other line. Here, what's the outside?
9.
9 times
15 plus 9.
9 plus 15 or 15 plus 9. Yes. Okay, we already talked about this left side. We distribute to both. 8x plus 64. Here, I can distribute if I wanted, but what can I also do?
Add them and then multiply.
Add those together and then multiply. So I get 9 times 24. So let's multiply that out. What is 9 times 24? 216. From here, what do I do? Subtract 64. 8x equals 152. Last step here. Divide by 8. X equals 19. Okay. All right. That's the all she wrote for the math portion. Okay, but what can you not forget about? Vocab portion. Okay, which you have had for a week now. Okay.
Yeah. Yes.